So I just want to go through my code here first for the Simon game. So what I have here is a load of packages that I'm just importing to make stuff work. So we have Bluetooth functionality, machine, which gives access to the hardware on the microcontroller, advertising for Bluetooth low energy, MicroPython const, so we can define constants in MicroPython. Bind ASCII, just converts the binary to ASCII. Time, so we can have time functionality. Struct, which is used for packaging binary data. NeoPixel, just to be able to use the RGB LEDs on the breadboard. And uRandom, which is a MicroPython random number generator. So we have here just all our Bluetooth events that are triggerable from the device that's connected, so the phone in this case. So these are just for triggering when the device connects, the device disconnects. This event is for when the device writes to the PicoW. We have another event when the device wants to read from the PicoW. Here we just have the characteristics and basically do the same as these events. It's just characteristics for when you want to read, write without a response, notify, and acknowledgement indication. So here we have the Bluetooth UUID for the Bluetooth service, and then we have all the different characteristics. So one for voltage, one for LED, one for the button, one for RGB, and one for starting the game. This is the only one we use in this code, actually, sorry, the start game characteristic. So it's able to read, notify, and write. So just when the device writes to start the game, we use this characteristic here to start the game. Here we just have a BLE service that includes all of the above characteristics, and then here we start the Bluetooth low energy class. So we're just defining the class, we're activating the Bluetooth low energy, and then we're activating a interrupt handler for any of the events, these events that happen. So here we just have some variables that are used just for storing attribute values. So these can be written to or read from. Here we have the start game changed. So it's just when the status of the start game changes, it's able to start the game then. And we have start game attribute. We also have RGB and LED. So here we're just registering the Bluetooth service and getting the characteristic handles. We're initializing the characteristic values, and then here we keep track of the active Bluetooth connections. So we're just advertising then as Simon game. This just displays to the user the MAC address, and then once it starts advertising, and then we can start advertising the Bluetooth low energy service here. Here we just have a couple of events that happen. So here, if the user connects a Bluetooth device to the PicoW, which lets the user know that that connection has been established. This here is just to restart the advertising when the connection is lost. Here, the user is notified when the Bluetooth device starts the game. So it's just looking for the user to input a value of 1 into the start game attribute. And then once that happens, the game is started. It also just lets the user know there with the got a game start request printout. If there's a error with the Bluetooth advertising, the user will be notified as well. Just prints error starting advertising. So here we just set up a class for the flash memory chip, which is used to store the high score information for the game. So we just set it up here. We enable writing to the flash memory. We have a read register to check the busy flag. We can check if the flash memory is busy. And then we can read bytes starting at the given address. So we have an address for the for the high score information. So we can read from that. Here we can write from that address, or write to that address, the new high scores. And then we can erase a section of memory at that address. This is the address we're storing the high score at. It's just the first address there. Here we can retrieve the flash memory object, so just starting it, setting it up, and then we can read the high score from the flash memory here. I also, for debugging, put in the ability to erase an old high score, save a new one. It's just useful for demonstrating the code. And then here we have the Simon game portion of the code. This is basically just one big loop. And then here we just set up all our different variables for that'll be used in the game. So we have our RGB LEDs here. We have a red button, blue button, green button. We're just using the machine to define which pinouts they are. And then we have here the 3 different options that the game can choose from. So it's going to have it has a random number generator built into it. So it can pick from any of these 3 options, 1, 2, or 3, which just 1 just means red, 2 means blue, and green, or sorry, 3 means green. You can also keep track of the current score of the player. Set up a variable there for that. So then we need to set up the flash, and it'll print the current high score to the user, and then the game starts. So if it's looking to see if the start game status has changed, so when the user writes the value of 1 from the Bluetooth device, it'll then start the game. We have a game array, which is just used to store the current 3 colors that have been randomly selected, and then we just generate a random color sequence to store into that game array variable. And we have 3 here, so it's going to only choose 3 different colors. Here we're just using the urandom, which is a Python add-on that we included in this, and it'll just get a random value between any of these options here, between 1 and 3, and then it'll place the selection from 1 to 3 into the first slot of the game array, just to keep track of what has been selected. And then every time it selects a color, it'll the code will look and see what value has been selected, and if it's 1, it's going to turn on the red LED. If it's 2, it's going to turn on the blue one, and if it's green, or 3, it's going to turn on the green one. Then after displaying it for a second, it'll turn off all the LEDs. So it does that 3 times, displays 3 different colors to the user, and then the game will wait to see what the user inputs. So we just have a new array which is used to store the button presses of the user. It'll print waiting for player input. There's a little bit of delay between the last color being displayed and the time that the user is able to input their choices. So I just have it printing to let the user know when they can input their choices. So it'll check to see if there's a button press, and it'll store it in the button press array. So it'll store 1, 2, or 3 depending on which button has been pressed, and let the user know which button they have pressed. And then it's constantly checking to see if there's a wrong input, so it won't wait till the user has inputted 3 different presses. It'll just check each time the user inputs a press, selects their color, and if they get it wrong on the first press, the second press, or the third press, it'll stop the game then. So it'll just let the user know that the game is over. It'll flash the red LED. It's a bit of a visual aid just to let the user know that they've made a mistake and the game is over. And then it'll display the current score to the player. Here, the code just checks to see if the user score was more than the stored high score. And if it was more, it'll print out new high score and store that information in the flash memory. Otherwise, it'll just print to let the user know that they haven't beaten the high score. The high score remains, and it'll print the current high score from the flash memory. Just here we have a bit more of the game code that will continue on if the user inputs the correct sequence. So if they have, it'll just let the player know that their combination was correct, and it'll increase the current score by 1. And here at the end, I just have a little debugging tool, so reset high score, which I can use to clear the high score if I need to. So I'm just going to talk through the game here. We start the game using the import function, and then we can start the Simon game portion of the code. So it's just displaying the current high score there, which was 3. And then if we go onto the phone, we connect to Luke BLE, which is the Pico W, and we write the value 1 into the start game attribute. It'll start the game and create a connection. We can see the game start request, and then it'll start displaying the colors on the LED. So here I am just inputting the combination, which was red, 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 and we can see a new combination now of blue, green, red. So as I input the button presses, it tells me which buttons have been pressed and then checks to see if the sequence entered was correct compared to the colors that were displayed. So I'm just going to play on for a little bit here until I get a new high score, and then I'm just going to input a incorrect sequence, and we'll be able to see what happens when an incorrect sequence is inputted. So there's the incorrect sequence there. It tells the user the game is over. The score was 4, which was a new high score, so that's now saved to flash memory. And now I'm just going to show off just the memory clearer, just so we can reset the memory if we need to. So we just run the reset high score. And that will clear the memory back to 0.